All right, welcome again to the night class. Today we're going over our exam review for Advanced Math Plus. Fun times. Everybody's loving it. It's like, okay, maybe not. All right, so chapters 1 through, what did we get to, 5? Wow. Did a lot of math. Did a lot of math in 9 weeks. All right. Started off with some easy ones. I think they're easy anyway. State the domain and range of the relation, then determine whether the relation is a function or not. So, domain is just the what? X's. So, for this one, the domain is, what are the X's? 3, 1, and 3. Do I have to say 3 twice? No. Okay, so 3 and 1. Your range is the Y's. 6, -3, -4. And for it to be a function, what can't repeat? The X's. Did we have X's repeat? Yeah. Yes. So this is not a function. No.
This is why I thought math was supposed to be easy.
Yeah.
Yeah.
Okay. Questions on 1? Awesome. Number 2. Determine the domain of this function. Well, remember, this is just one of those questions where basically you're figuring out what X can't be. Okay, because you can't divide by what? What can you not divide by?
0.
0. So we have to figure out what would make 0 on the bottom here. Okay, so can that X be 0? Right here, this first one? No, because if it's 0, then whatever you're multiplying by here will become what? 0. Okay, so I know it's all real numbers, but it can't be 0. X can't be 0. And then x squared minus 49 can't be 0 either. So if I wrote that out and solved it,
Can't be 7.
I would get x squared equals 49, and I take the square root, and so x can't be 7. It is, or -7. Okay? It can't be 7 or -7. Everybody good? So it can be any number except those 3. And again, you just figure out what would make the bottom 0.
X squared minus 49?
It was x squared minus 49, yes. Number 3, one more time, finding the domain and range, 3 and 4. They're giving you graphs. So we also have to state whether this is a relation or not. So my domain here for this graph, it goes how far left?
All the way.
How far right?
All the way.
So it's all real numbers. The range, does it go forever down? No. Does it go forever up? Yes. So we got to figure out how far down did it go. Where did it go down there? -2. So y has to be greater than or equal to -2. Okay? And is that a function or not? Yes, it passes the vertical line test. Okay? So it is a function. All right? Number 4, a little harder. Shape. It's not all real numbers here. Domain. How far does it go to the left? Well, it goes about right there. So what point is that?
-3.
-3. And how far does it go to the right?
7.
7. So 1, 2, 3, 4, 5, 6, 7. So it goes from -3 is less than or equal to x, which is less than or equal to 7. You do the same thing with the range, but you go up and down. So how low does it go? -7, and it goes up to
3.
+3. So -7 is less than or equal to, the range is y, less than or equal to 3. Is that a function? No. If you drew a vertical line, it touches more than once. So that is not a function. Any questions? Pretty easy? All right, number 5. What does it mean when it says f minus g of x? You're just doing what? Subtracting. What from what?
F of x from g.
F of x minus g of x. So what is f of x? 4 minus x squared minus, what is g of x? 2 minus x. Notice, put your parentheses because you have to do what with that negative now? Distribute, okay? Distribute. So that will be 4 minus x squared minus 2 plus x, and then you just simplify that. So we got negative x squared plus x plus 2. 4 minus 2 is 2. Very good on 5. All right. And like I said, if you missed something, you can always go back and watch the video. All right. 6 says given f of x equals x minus 2 over x and g of x equals x squared plus 3, find g of f of 3. And it even kind of tells you, gives you the kind of hint, okay? So basically, what are we going to find first? I just underlined it. F of 3. So I find f of 3 first. That is 3 minus 2 over 3. Everybody understand how I did that? I just took 3 and plugged it in for the f of x. Okay?
Where did you get the 1/3 from?
So you did
I
it.
subtracted. 3 minus 2 is what? 1 over 3. What do I do with that answer? I plug it into g. So I'm taking this, okay, and putting it in for g of x. So g of 1/3 equals 1/3 squared plus 3. That's 3 plus 1/9. 3 and 1/9. I don't know how it has it in your answer. It looks like it. 28 over 9. Okay. I would take either answer, but remember the exam will be multiple choice, so you have to pick whichever one they want you to pick. Okay.
Where did you get the 1/3 squared plus 3 at?
That's what g of x was. X squared plus 3. So what am I plugging in for x? 1/3, and you figure it out. Okay? Tried to make these as easy as I could. All right? 7. Determine whether the graphs of the pair of equations are parallel, perpendicular, coincident, or none of these. If they have the same slope, they're what? Parallel. If they have the same slope and same y-intercept, they are coincident. Okay? If they have opposite reciprocals, they are perpendicular. And if they just have different slopes, they're just nothing. None of these. Okay? So these have what?
How do you know if they're coincident?
Opposite reciprocal.
How do I know if everything's the same? Yeah. If everything's exactly the same, they're coincident. Okay? So what?
Opposite reciprocal.
There are opposite reciprocals, so these have to be perpendicular. Okay? Very, very simple there. 8, you're writing an equation for a line that is parallel to y equals 3x minus 1 and passes through point 8, 1. So if you've forgotten how to do these, I'm going to write my, anybody remember what that's called? What form? Slope-intercept form. If it's parallel to this line, what is the slope I'm going to use? 3. So I know m is 3. Okay? It has to go through point 8, 1. That's my x and y. So x is 8, y is 1. So I plug in 1 for y. I plug in 8 for x. And now I just look for what? B. I look for my y-intercept. That'll be minus 24. 3 times 8 is 24. Subtract 24 over here. Negative 23 is B. So now I have my B. I have my slope. You just write the equation. Y equals 3x minus 23. There is your final answer. Okay?
See, I forgot the formula, so I just started plugging numbers in.
So what'd you minus the 24 from?
3 times 8 is what?
24.
And I'm moving it over because I'm trying to get b by itself.
How are you moving it? Why?
Why am I moving it over?
Yeah.
To get b by itself.
Is that a 1 or what?
That's a 1. That better? Yeah, that's a 1. 9 and 10 are calculator problems, okay? You need to make sure your calculator mode is in the stat diagnostics is on. Excuse me, I can't talk. So hit mode and make sure you scroll down where it says stat diagnostics and it should say on, okay? And then all you are trying to do is figure out what R is. Okay, so it's literally just the whole thing's using your calculator, okay, which I know y'all love. So I'm going to kind of show you how. Let me get out of this real quick. You go to Stat, Edit. You're going to plug in L1 is the 8 X's, so in this case the age. So you had 25.
Wait, where you guys go?
Stat, Edit. 36, 42, 25, 45, 28, 36, 37, 32, and 46. And then for L2 is the bottom of the resting heart rate, so that's 65, 46, 58, 66, whoa, wrong number, 66, 57, 42, 73, 70, and 59 and 70. Okay. And it says, what does the Pearson product moment correlation value R mean? So, I hit stat one more time. I scroll over to Lin Reg, number 4, and I calculate, and it should tell you your R. What is my R here?
0.1436.
0.1436, blah, blah, blah. Okay? What does that mean?
There's a weak correlation.
It is a weak positive correlation. How do I get what? You hit stat, go over to calc, number 4. Yes, sir. Everybody good? All right.
And it's weak because it's not close to 1.
It's weak because it's not very close to 1. Correct. The closer R is to 1 or negative 1. Okay? It could be negative 1. The closer they are to 1 or negative 1, the stronger it is. If the closer it is to negative 1, the stronger negative correlation it has. The closer it is to positive 1, the stronger positive correlation it has. Everybody got me? Okay? So, just to save time, because like I said these are just plugging in, okay? You can test them out again later. Oops, wrong page. Here we go. So R here was, what did I say it was? 0.1436, which means it is a weak positive. Okay. If you plug in number 10, you should get R is 0.979. Again, I'm not going to waste the time of plugging it in because we're kind of in a hurry. So you can do that later. You should get 0.979. What kind of correlation is that? It is positive. It is a strong positive correlation. Okay, and then you got one more, I believe, number 11. It says use a graphing calculator to find an equation for the line of regression and the Pearson product moment correlation value R for the data in the chart. The chart below shows the years of work experience of 8 administrative assistants at Morris & Company and their hourly wage. If the correlation value R for the regression equation shows a moderate or strong relationship, use the equation to predict the missing value and explain whether the prediction is reliable. So, for the 11, you need to plug all the numbers in except that last one, because the 30 doesn't have a buddy to go with it. Does everybody see that? Okay, that's what you're trying to figure out. So you're going to plug all the numbers in except that, and you will see that your R is, let's see here, what is it? Strong. It doesn't tell me what it is. It just told me it was strong. What is your R when you do that? 0.9787. Okay, so yeah, that's definitely strong. So what is the equation that it gives you? It should tell you A
is 0.3471.
X, and then what is B?
6.3901.
6.3901. So there's your equation. And now what do I do to figure out the hourly wage for 30 years of experience? Plug in 30. So Y equals 0.3471 times 30 plus 6.3901. That should be, according to my answers, about $17. Okay, remember it's going to be multiple choice, so just kind of pick the answer that you feel is the closest to what you got. Okay? Everybody understand those calculator problems? Everybody good? All right. Number 12. Let me come back to blowing it up, big screen. All right, so 12, it says to graph. So I'm going to graph over here as best I can. Anybody remember what these are called?
I just know they're like different lines going everywhere.
They're in pieces. It's called a piecewise function, okay? And so basically we just need to make two XY tables, okay? So one of the XY tables will start at 2, well they'll both start at 2 actually. But one will be the numbers before 2 and one will be the numbers after 2, okay? So it says to do less than 2 first. So what's less than 2? 1, 0, -1. It's up to you how many you want to do, okay? The second one is greater than or equal to 0, so we'll do 2, 3, 4, and 5, okay? For this first table, where am I plugging these numbers in? Top or bottom equation?
Top.
The top. So -5 times 2 is?
-10.
-10 plus 2 is -8. -5 times 1 is -5 plus 2 is -3. If I plug in 0, what do I get? 2. And if I plug in -1, what do I get? 7. Okay? Over here on the other one, where am I plugging these numbers into? The bottom. So 2 times 2 is 4, minus 2 is 2. 2 times 3 is 6, minus 2 is 4. 2 times 4 is 8, minus 2 is 6. And 2 times 5 is 10, minus 2 is 8. Okay? So, over here, this point, right here, the 2, -8, it's actually what? What kind of hole should I put there, or dot? Should it be solid or open?
Open.
It should be open because it was just less than 2, okay? So I'm going to go to 2, going to go down to -8, which I didn't quite make my graph big enough, so that's 4, 5, I'll make it a little bigger. 6, 7, 8. So it starts right here, and it's an open circle. Okay, again, it's open because it was just less than. All right. The rest of them will be closed. 1, -3 is right there. 0, 2 would be there. And -1, 7, I'm not even going to graph that one because I don't have room, so I'm just going to show you it just keeps going that direction. Okay? Then I come over here to the other one. 2, 2. Right 2 up 2. 3, 4. 4, 6. 1, 2, 3, 4, 5. 6 at the very top. And like I said, I'm not gonna worry about 5, 8. I can see what my graph is doing. It's going forever in that direction. Okay? Again, it's gonna be multiple choice. So basically, you just need to make sure you pick the right graph. Okay? Make sure the hole is where it should be. Can anybody tell me why that has to be open?
It doesn't have a line. It's not equal to.
It's not equal to, but look at your graph. Why does it have to be open? If this is f of x, tells me it's a what?
Function.
It has to be a function because they wrote it in function notation. So
you can't have. It wouldn't pass the vertical.
because
line
it wouldn't pass the vertical line test if one of these points was not open. Does everybody understand that? Okay? All right. 13, use the graph of y equals absolute value of x to graph y plus 3 equals the absolute value of x. So, I am going to erase my beautiful graph over here so we can make a new one.
If I'll work some of this on a piece of paper while the use it still at best.
If you work some of this, yeah.
We turning this in after the exam?
Yes, you'll turn it in with the exam. Okay, so what do I need to do first, obviously?
Coach Knight, can this be a test grade instead of a quiz grade? Because this is like more important.
I bet the
Good
exam
try,
can
though.
be an exam grade.
Did you have your hand raised?
No.
Oh, okay. All right, so we need to subtract 3 over first. So we have y equals absolute value of x minus 3. Make my table. What kind of graph is this going to look like? What kind of shape?
A V.
A V, okay. Is it going up or down? It's going up because there's a positive number in front of your absolute value, okay? If it said negative absolute value of x, then it would be going down, okay? So we always start with the vertex. If you forgot how to find the vertex, you try to make the inside the absolute value 0. So in this case, it's just what? 0. And if you plug in 0, you get -3. I'll just do 1 and -1. That will give you -2 and -2. And you graph it. So we got 0, -3, 1, -2, -1, -2. Draw your V. Okay. Again, the graphing problem should be easy because if you do forget, you can always just put it where? In your calculator. Everybody knows how to get absolute value on their calculator, right? Second. It's second, 0, and it's the very first. It says abs. ABS is absolute value. Okay? And then you just have to plug it in.
Do we have to show work on the exam?
Nope, you don't have time. Treat it like the ACT. Okay? Everybody good on 13? 14. Long problem if you do it by hand. If you do it with your calculator, it's not so bad. Okay? Some of you may have even forgotten how to do it with your calculator. Some of you may have forgotten how to do it by hand. Okay? by hand, you have to go, right now we have 3 variables. We have to get it down to how many?
2.
2 equations with 2 variables, and then we'll break that down into 1 equation with 1 variable, and then work it way back up, okay? But the quick, easy way is to use our friend, the calculator, okay? I don't recommend doing it like this all the time. 1, because you don't always have a calculator, so you do need to know how to do it, but like I said, there's 50 questions on the exam. You got an hour and a half, so you need to do everything as quickly as you can, okay? So if you have forgotten, I'm going to make a matrix. Y'all remember that? Matrices, okay? And you have your coefficient matrix, your variable matrix, and your constant matrix. So what are the coefficients over here on the left? What's this coefficient? 1, and the one for y right here is also what? 1, and then the one for z is -1. And then the second row, you got -6, and 1, and 4. And the third row, you have -6, and 5, and 9.
So can't you just like plug in like your X, Y, and Z and from your multiple choices into?
You absolutely can plug and show, yes. But make sure at least it works for 2 of them, I would say, at least. I would plug them into all 3 and make sure they all work, because they could give you one that works for one of them and doesn't work for the other 2. You got me? So just to be on the safe side of there. All right, what are my variables? Crickets.
Oh, X, Y, and Z.
X, Y, Z. There you go. Thank you. Okay. So that's my variable matrix, and it has to equal my constant matrix, which is -10, 19, 14. All right, so how many of my genius students remembers how do we get rid of this and move it over there?
Don't you just change that to sign?
Nope, close, not really close, I should say.
Do you just add it?
No, you just did it. How do we get rid of sign?
Inverse.
You do the inverse. You do the inverse of that matrix. Okay? So, in your calculator, we're going to let this be a matrix, and I'm going to do the inverse of it. Okay? So, I'm just going to, here, let me get rid of that graph. We don't really need it anymore. So, to get my answers, here's what I'm going to do. I want to, okay? So, X, Y, and Z. I'm just writing them like that. They're going to equal that matrix, that first one, 1, 1, -1, -6, 1, 4, and -6, 5, 9. But it's the inverse of that matrix. Okay? You do it to the -1 power, in other words. All right? Times your constant matrix, -10, 19, 14. Okay? So, on your calculator, you go back to our trusty handy dandy calculator. Anybody remember how to get to the matrices? Alpha and zoom is the quickest way. That way you don't have to go through labeling matrix A, matrix B, and all that good stuff. Okay? It just goes straight to it. So let me clear this out. Alpha matrix, how big was our first matrix that we're making? It was a 3 by 3, so I come over here, I click 3 for the rows, scroll down, hit 3 for the columns, and hit OK, and then I plug them in. Do not hit enter, okay? Use your arrows. If you hit enter after you plug in the numbers, it's going to say you're done, okay? So don't do that. Bless you. All right, so my top row was 1, 1, -1. Okay, my bottom row was -6, 1, and 4. And then my bottom row is -6, and 5, and 9. Okay? Everybody good? And I want the inverse of that, so I hit this little x to the -1 button. And then I hit alpha, zoom, and my constant matrix is how many rows? How many rows? 3 rows, but only 1 column. Okay? Go down, hit OK, and I plug in my constant matrix, which was -10, 19. I hit enter. Remember, guys, don't hit what? Don't hit enter. I can't even follow my own rules. Okay. It's all right. I come in here. We'll fix it. So, 19, arrow, not enter. 14, arrow, done. All right, hit enter, boom. So what's x? -2, what's y? -5, what's z? 3. X is -2, y is -5, z equals 3. Okay? And if you do hit enter by mistake, no big deal. Just hit second enter and it'll bring it back up and you can fix what you didn't do. Okay? Or you can take the time to plug in the answers and see which one works.
This seems longer.
It only seems longer because you haven't practiced doing it as much. Okay? Everybody good on that? Alright?
Can you go back to your work?
Okay, so once I have it on the business,
Say again. You good, Nate?
What was it? -2, -5, -3.
Is that right? Is-
-2, -5, 3.
-2, -5, 3. Everybody good? I only gave you one of those. You're welcome. I know you're appreciative. The other matrix problems are actually pretty easy. Can you use your calculator on these two? Yeah, but I wouldn't recommend it because 15 is really easy. It's just adding. So it's just going to be you add up the parts. So -2 plus -5 is -7. 8 and -2 makes 6.
We had a question like
1
this.
and 1 makes 2. Ma'am?
We had a question like this in the ACT.
On the ACT? Good.
Yeah.
7 and -7 make 0. 0 plus 2 is 2. 4 plus -1 is 3. And then -1 plus 3 is 2. -5 and 5 make 0. And 6 and -4 make 2. Done. Okay? You can use it on 16, your calculator, if you would like. Okay? Because remember, multiplying is a little more complicated than adding. So I probably would, just to make sure I got it right, so I don't make any mistakes, okay? But I'm going to do it the long way for you. First off, in order to multiply them, remember, this matrix, how big is it? It's how many rows? 2 by 3. And this one is a 3 by 2. These two inside numbers have to be the same in order to multiply matrices. Okay? How big is my answer going to be? Nope. It's a 2 by 2. I can't tell you how helpful it is to know that, especially in a multiple choice test. Okay? If they give you a couple of answers that aren't 2 by 2 matrices, guess what? They're not right. Okay? You got me? For your answers. If it's not a 2 by 2 matrix, you can cross those out. Those can't be it. All right? So, the two numbers in the middle have to be the same. The two numbers on the outside tells you how big the answer is. Okay? So, if you have forgotten how to do it, we say 0 times 1 plus 2 times 0 plus 1 times -3. Okay? Row by column. All right? 0 times 1 plus 2 times 0 plus 1 times -3. All right? Then we do that same row by the second column. So 0 times 3 plus 2 times 1 plus 1 times -3. Okay? And then we go down to the second row times the columns. So the second row would be 5 times 1 plus -1 times 0 plus 0 times -3. And then last but not least, bottom row times second column, 5 times 3 plus negative 1 times 1 plus 0 times negative 1. And you just simplify those. So this first one right here would be negative 3. This one here, that cancels. 2 minus 3 is negative 1. Here, those cancel. You're left with 5. And the last one you have, that one cancels. So 15 minus 1 is 14. There's your final answer. Okay. Everybody good?
And the calculator way is the way we just did it on number 14.
No, the calculator way is you would just multiply these matrices.
Yeah,
Okay.
can we do it that way?
On the top,
Yes.
on the top second one, wouldn't it be, negative 1, not negative 3?
Wait, what?
Just for here?
Yes, sir, because you have 3, 1, and negative 3. Wouldn't it be 3, 1, negative 1?
Did I mess up? Let me see. 0 times 3,
I got positive
2 times 1. That's right. It is 1 times negative 1. You're right. Thank you, Emily. Sorry about that. So that would be, what, positive 1 there, huh?
Yeah.
Okay. Thank you. Thanks, Em. Yep, I was wrong. I just checked it. You're right.
What was?
Good job. So you said you did want me to show you how to do it with the calculator?
I know how to do it with the calculator.
You sure?
Yes, sir.
Okay. Does anybody need the calculator way, Sean? Harris does. All right. You ready? You got your calculator? All right. So you just hit second zoom or alpha zoom. These were both 3 by 3s. Is that right?
No, sir.
No, they were what? 2 by 3. The
2
first
by-
one was a 2 by 3,
2 by 3 and then 3 by 3. No.
and the second was a 3 by 2, right?
Yeah,
Okay.
3 by 3.
So, doing the 2 by 3 first. Let me find the problem so I can. There we are. Okay, so you had 0, 2, 1. Make sure you hit the arrow. Okay. Not enter. 5, negative 1, and 0. Okay. In. Hit the right arrow after you type them in.
Will it do an error
If you try to multiply 2 that can't be multiplied, yes, it will. It should say error. Okay. You good there, Paris?
So if we're getting rid of one in school,
You good? Okay. So then you do alpha zoom. The other one was a 3 by 2. So I changed the size of it. Hit OK. I plug these in. You got 1, 3. Dang it! I did it again. Don't hit enter. So how do I fix it? Second enter. It goes back, and I just go back and fix what I messed up. Okay. So 1, 3. Hit the arrow button. Silly Coach Knight. It's 0, 1, negative 3, and negative 1. And then you just hit enter. Your calculator knows that that's multiplication. So negative 3, 1, 5, 14. Okay? Piece of cake. All right. I'm going to hold us right there for a second because we'll be right back in just a minute. 17. They give us this matrix. It says use matrices to determine the coordinates of the vertices of the translated figure, then graph the pre-image and the image on the same coordinate grid. Triangle DEF with vertex matrix negative 1, 5, 7, 4, 5, and negative 8. Translated 2 units left and 1 unit down. So, first off, does everybody understand how to graph this? That's X, these are Y's.
Oh, yeah.
So you go left 1, up 5, and you make a point. Then you go right 7, up 4, make a point. Right 5, down 8, make a point. That's your original. They want us to translate that triangle, 2 left and 1 down. So to this matrix, okay, we're going to add, how do we go 2 units left? What do we put?
Subtract.
Subtract what?
2.
2. So -2, -2, -2. And to go 1 unit down,
Subtract 1.
we do -1, -1, -1. Notice, I put -2 in the x parts, -1 in the y parts, and we just add these up. Okay? So you have -1 and -2 make -3, 7 and -2 make 5, 5 and -2 make 3, 5 and -1 is 4, 4 and -1 is 3, -8 and -1 is -9. That's going to be the points of my new image. Okay? And like I said, on your exam, they'll have them graphed. Okay? They'll actually have the triangles graphed for you to look at as well. Okay? Any questions? Everybody good? 18 and 19, we're going to go back to our calculator, but what are they wanting when they do absolute value around a matrix? What's that called? Y'all remember it started with a D?
Discriminant.
Close. A lot of people get discriminant and determinant mixed up. I understand why. The discriminant is the part that's under the square root in the quadratic
I was
formula.
saying something I
Oh, you just, okay. This is the determinant, okay? This is also something you can do in your calculator, all right? So, go to your calculator. If you will hit second and x to the -1. You see how matrix is in blue right there, okay? It brings all this up. You need to go over to 1 to the math, and the very first one says DET. What do you think that might stand for? Determinant, okay? So I want the determinant, and then you just plug in your matrix, okay? So alpha, zoom, it was a 3 by 3, correct?
Yes, sir.
And we're going to plug it in. So we got -3, don't hit enter, hit the arrow, 1, 4, and then -2, 5, and 3, and -1, -4, and 2. And close your parentheses and hit enter.
So where was the determinant at again?
You hit second, the little x to the -1 button, where it says matrix in blue, and go over to the one to the right, and it's the very first one at the top. So what is my determinant? -13. Done. That's all you have to do. Okay? So this equals -13. And just kind of refresher, if your determinant is 0, that means the matrix doesn't have a what? Do y'all remember? It doesn't have an inverse. Very good. If the determinant is 0, it doesn't have an inverse. Okay? 19, they're asking us to find the inverse. So, all that means is we put this matrix in our calculator and do the -1 power again. And that's it. Okay? It will give us the answer. So, go back to my calculator. That was a 2 by 2, right? So, alpha zoom, change my dimensions to 2 by 2. And I plug them in. We got -3, arrow 4, arrow -2, arrow, and 1. And I hit that little x to the -1 button and hit enter. And there you go. Okay? 0.2, -0.8, 0.4, -0.6. Okay? Thank you. If I wanted to change that to fractions, what could I do?
Math enter.
Hit math, enter, enter, and it's fractions. Okay? The reason I tell you that is because on the test, it might not give it to you as a decimal. It might give it to you in fraction form. Okay? It also on the test might give it to where you just have your 1 over the determinant on the outside before they have plugged it in. So remember that. Okay? Does everybody understand what I'm saying when I say that? Okay? So somebody read me that answer real quick. What was it? It was point
0.2.
0.2, negative 0.8.
0.4,
Negative 0.6. So here's the way they may have written it, because they wrote it like that on my answer sheet. 1/5 times 1, negative 4, 2, negative 3. Okay? These two things are equal. All right? So all you do to figure out which one is you just take your 1/5 and do what? Multiply it by everything in the matrix. Okay? That will give you this. Everybody good? Okay? All right, 20. Whew. That was good. That was good. Took a good long time. 20 does not. All right? Is that even, odd, or neither? It is even because all my exponents are even. If they are all odd, it's odd. If you have some that are even and some that are odd, it is neither. Everybody good? If it's just a number, what's its degree? If it's just a number with no variable, what's its degree? 0. If it just has x, what's its degree? 1. Okay? Keep those straight. All right. 21, we've done these quite a few times. F of x, g of x, whatever you want to call it. It was here, and now it's over here. So it went how far? 1, 2, 3, 4, 5 to the right, and 1, 2, 3 down. So where do I put the 5?
In the absolute.
In the absolute, do I say plus or minus? I do minus because I do opposite. So minus 5. And then on the outside, I put minus 3. Okay? I can't tell you how many times I think that same question was on the mid-test, and I think the exact same question was on the whole chapter test. So you've seen this question quite a few times, and it was on both reviews. So if you missed this one, you're just not trying. Okay? All right? You've seen it quite a few times. 22. Again, these you can just plug in your calculator and graph them. Okay? What do you need to remember about the graph when it's an inequality there? If it's greater than, you're going to shade what? Up. And if it's just greater than, what kind of parabola am I going to have?
Dotted.
It's a dotted
So
parabola.
like this
Okay?
question, are you gonna give us like 4?
There will be 4 graphs.
Okay.
And I don't know for certain what I'm saying is true. I just know from experience. They usually have 2 of them, okay, that are graphed, like 2 of them will be solid lines. 1 will be graphed up, 1 will be graphed down. 2 of them will be dotted lines. 1 will be graphed up, 1 will be graphed down. See what I'm saying?
Yeah.
So you have to figure out which combination is correct. Okay? So just know for this one, it's going up and it's a dotted line, okay? And since it's greater than, we would shade up, which would shade everything in the middle. Okay? Is that making sense? So you're looking for one that's a dotted line that's shaded inside. All right? Like I said, your options, you'll probably have one that's a solid line shaded inside. You'll have one that's going the other direction maybe, shaded inside, and one, you understand what I'm saying? There's a whole bunch of options they could give you. But what you need to know is, hey, greater than, I shade up. Inside or outside, doesn't matter. I go up, okay? No equal sign means dotted line. If it has an equal sign, it's a whole line, okay? Yes, sir.
I was kind of confused about like shading up and down.
Okay.
If the parabola is going down and you need to shade up, would you shade on the outside?
You sure do.
Okay.
Yep, you shade everything on the outside. Okay? Same thing for 23. Only difference is it is a absolute value. Okay? Solid line or dotted.
Dotted.
Dotted again, so we're going to have a dotted V. Would we shade up or down? Up. So that puts us inside it again, okay? And again, they'll have three options that kind of look like that, but aren't really, okay? Everybody good on those? 24 says solve the inequality. 24 is where you have to remember the little jingle, less than and, greater than or, okay? That will also help you answer the question, because if I don't know for a fact, again, I'm just going off the experience, they'll probably give you two answers that are ands and two answers that are what? Ors, okay? So if you just know which one it is, you're probably going to have a 50-50 chance of getting it right, okay? So this is a greater, remember, okay? So I say 3x plus 6 is greater than 1, or 3x plus 6 is less than 1. I subtract my 6 over on both sides. That'll be 3x is greater than negative 5. Divide by 3. So x is greater than negative 5/3. Or over here I subtract 6, I get 3. Oops, what I forget to put on my 1 here? Negative, it's negative 1. Sorry about that. 3x is less than negative 7. Divide by 3, divided by 3. X is less than negative 7 over 3. So that's my answer. It can be greater than negative 5 over 3, or it can be less than negative 7 over 3. All right? Yes. 25 says, without graphing, describe the end behavior of the graph of g of x equals 2 times x to the 4th plus 1. So these are the problems where we plug in infinity and negative infinity and see what you get, okay? So we plugged in infinity, we get 2 times infinity to the 4th plus 1. Again, do you really care about the plus 1? No, because we're talking about going to infinity, so that plus 1 really doesn't have any effect on it. If you do a positive infinity to the 4th power, it will be positive infinity times 2 is still positive infinity. So, as x approaches positive infinity, f of x approaches positive infinity as well. Okay? And they may write it opposite of the way I'm writing it. I'm looking, nope, they write it that way. Okay. I did put f of x, it should be g of x there. Sorry. Not a big deal. Remember, your exam is multiple choice, so you'll have choices to choose from. And then we need to do, as x approaches negative infinity, g of x approaches what? Well, let's see. If I made that infinity there negative, does it change anything? No, because negative to the 4th is still going to be positive, times 2 would still be positive infinity. Okay?
Is that like a rule that like if it's even they're the same, if it's odd they're different? For like the end result?
Yeah, but you need to remember, be careful about the coefficient that's in front. Okay, so if it's
Yeah, like if it's a negative, it changes.
Yes. Oh, I know. Yeah, you remembered that. Yes, good. Yes, if it's an even degree, what they approach will be the same. If it's an odd degree, what they approach will be opposite. Okay? So yes, I did say that. So here, like we have an odd degree. Okay, again, don't worry about that part. Just worry about the 3x to the 7th. I know since that's odd, I'm going to have g of x is going to be approaching infinity for one of them and negative infinity for the other. Okay? So, as x approaches infinity, g of x approaches, well, let's see. If we plugged in positive infinity there, what would we get? Positive infinity, okay? Because it'd be 3 times infinity to the 7th power. That's just infinity. So, as x approaches negative infinity, though, I need more room. I need more room. G of x will approach, well, let's see here. If I plugged in negative infinity, 3 times negative infinity to the 7th. Negative to the infinity to the 7th is negative times 3 would stay negative infinity. So, as you can see, one of them it goes to positive infinity, the other one it goes to negative infinity. Why? Because it was an odd exponent. Very good. 27, you're finding the relative minimum and relative maximum points for this graph. That's a calculator problem. So we're going to graph it. So go to y equals and graph that equation. Make sure I read it correctly. It's x to the third minus 3x minus 4. And we hit graph. And here is my maximum right here. Here is my minimum. And you just let your calculator find it for you. So hit second trace. I'm going to do the maximum one first because it was the first one I come to. So I move my cursor to the left of it, hit enter, ask for the right bound, move it to the right of it, hit enter, hit enter. My maximum is, don't put negative 0.99999. Okay, that's -1, and then my y is -2. Okay, so maximum, -1, -2. Okay, minimum, well, let's go find it. So minimum, we're going to have second trace, go down to minimum, number 3, and we do the same thing. We move to the left. Here's the point we need to be left of, okay? So that's good enough. Enter, scroll to the right, enter, enter. 0.9999996, -6. So that is 1/6, okay? I did it again. 1/6.
Be -6.
Was it -6?
I thought it was.
All right. Let me look. I believe you, but yep, you're right. -6. 1 -6. All right. Any questions on how to do that? Pretty simple. Okay. Find the vertical, horizontal, and slant asymptotes. Remember, can you have all three at one time? You cannot. The most you can have it at one time is 2. Since our degree on the top is bigger than the degree on the bottom, we cannot have a horizontal asymptote. Okay? So it's just going to be the vertical and the slant. So to get the vertical, we factor this bottom part here. Okay? What two numbers multiply to be 4 and add up to 5? 4 and 1. So plus 4 plus 1. So what would make the bottom 0? What two numbers would make the bottom, the denominator, 0? -4 and -1. So x equals -4. X equals -1. Y'all may have said that. I just couldn't hear you. Okay. That's my vertical asymptotes. How do we get the slant? What do? It's that big long stuff that y'all hate doing. Long division. Yep. So we're going to say x squared plus 5x plus 4. 2x to the third plus 7x squared minus 6x minus 9. And remember, when we're doing this, we don't care about the remainder. We just care about what's on the top. Okay? So don't forget about that. So my slant, we're going to have y equals, and we got to figure out what y equals. Okay, so ask yourself, x squared times what gives you 2x to the third? And you should say 2x. So when you multiply these, you got to remember to put the opposite on the bottom. Okay? So 2x times x squared is 2x to the third, but I do negative 2x to the third. Okay? 2x times 5x is 10x, but I do negative 10x squared. Okay? And 2x times 4 is 8x, but I do negative 8x. And I add those up. So get negative 3x squared, negative 14x, bring down the negative 9. The 2x cubes go away. X squared times what gives me negative 3x squared? Negative 3. At this point, really, I can stop because I have what I need. There's really, the only reason to keep multiplying here is to get your remainder, and do we need our remainder for this particular problem? We don't. So my answer, my slant asymptote, is just y equals 2x minus 3. Alright? Everybody good? 29 and 30 and 31. It says find the constant of variation and use it to write an equation for each statement, then solve the equation. As I said earlier, remember it's going to be multiple choice, so it's quite a lengthy test. It'll take a while, so treat it like the ACT. Do whatever work you got to do to get the answer. Okay? And if you can do all of it in the calculator, do all of it in the calculator. If you can't, write it down. Okay? But I'm just going to be looking for A, B, C, or D. Okay? All right? So 29, do y'all remember varying directly? What does that mean they do? Y'all remember? I'll write it over here. All right, so direct is like y equals kx, okay? Indirect, or excuse me, not indirect, inverse is y equals k divided by x. That's an ugly k. And then we also had one called jointly. That is y equals k x z. That's when you just multiply by more than one variable. Okay? So direct and joint, you're both doing what? Multiplying. Inverse, you're dividing by your variable. Okay? And again, the variables can change depending on what it says. Like on this one, it says y varies directly as the what? The square of x. So that means we're going to have y equals kx squared, not just kx. All right? It gives you what y is and what x is. You have to find k first. That's the constant of variation. So we would have 8 equals k, x is 2 squared. So what is 2 squared? 2 squared is 4, so we're going to divide by 4. And what is k? 2. That is my first answer. K equals 2. Now it says to write an equation. So I just plug in k, right? So my equation is y equals 2 x squared. That's my second answer. And then it wants to know find y when x is what? 8. So what do we do with the 8? Plug it in. So y equals 2 times 8 squared. What is 2 times 64? 128. That is your third answer. Okay? Everybody good? So you got to find k in order to write the equation, and then once you write the equation, you just plug it in. All right? 30, very, very similar. Only this time it's what? Inversely. So now we say y equals k over x. Again, because it's just inversely as x. It gives me y. Y is what? 1/2 equals k over x is 3. And basically you just multiply both sides by 3. K is going to be 3 over 2 or 1.5, however you want to write it. So write the equation. It's just going to be y equals 3 over 2x. You just put the x down there at the bottom. So there's your equation. And then they want to know what is it when x is 5. So y equals 3 over 2 times 5. That's 3 over what? 10. Done. Okay? 31, as always, it's written incorrectly. It says directly. What should it say? Should say jointly, okay, because we're multiplying by two things here. But same thing, it doesn't matter. Y equals k times x times z, okay? So plug in, what is y? 32 equals k, x is 2, z is 4. What is 2 times 4? 8, so divide by 8. K is, what's that, 4? Is that right? Okay. Plug that in for my equation. Y equals 4 x, z. And then they want to know what is y when x is 5 and z is 2. So y equals 4 times 5 times 2, which is 40. Okay? Everybody good? All right. 32. Make sure I get on the right track. Yep. 32 is a multiple choice question already. And since you have your calculator, what's the easiest way to do this? Put in y equals. Okay? Do your answers. Plug them in and graph them and see which one goes through where?
X-axis.
-5, -1, and 4 on the x-axis. Okay? That's one way of doing it. I, of course, is the teacher, so I'm going to show you the long way. But anyway, or technically it could be the short way, depending on how long it takes you to multiply. So we would have, let's see here, x plus 5, x plus 1, x minus 4. Does everybody understand why I'm changing the signs? Yes? Okay? And then you just multiply it out. So that's going to be, let's see here, x squared plus x plus 5x plus 5. So x squared plus 6x plus 5. And then we multiply that times x minus 4. X squared times x is x to the third minus 4x squared, minus 4x squared. 6x times x is 6x squared. And 6x times -4 is -24x. And then last but not least, 5x. And 5 times -4 is -20. And then you just add all that up. So x to the third plus 2x squared minus 19x minus 20. Okay? So which answer is that? A. See, if you started off with A, it would have been a lot quicker just to plug it in. Okay, the calculator, and see where it's crossing the x-axis. All right? It's up to you. Whatever way you feel is more comfortable. All right? B, it says find the discriminant. The discriminant, if you've forgotten, is that square root part of the quadratic formula. Okay, it's what's under the square root. So do y'all remember what's under the square root? B what?
Plus
B squared minus
A.
4AC. That's all you got to remember. Okay? So I plug in. What is B in this problem? 2. A is also 2. So 2 squared minus 4 times 2. And C is -4. You plug all that in and you get 36. That is your discriminant. And if you get 36, that means you have what kind of roots? What's the nature of them? 2 what?
2 real.
2 real. 2 real roots. Had it been 0, you would have put 1 real root. Had it been negative number, 2 imaginary roots, or 2 complex roots. Means the same thing. Okay? Everybody good? Yes. If it's a negative discriminant, you get 2 imaginary or 2 complex roots. If it's 0 for the discriminant, you have 1 real root. And if it's positive number, you have 2 real roots. Okay? And another way you can kind of cheat on that, Haley, not cheating, but you're using your tools that you have. You can plug it into your calculator and count how many times it crosses the x-axis. Okay? If it crosses it twice, then you know you have 2 real roots. If it just comes down and touches it once, it's 1 real root, and if it doesn't touch it at all, it's imaginary or complex roots.
Everything we write on
Yep. Okay. 34. Again, which one of these is not a factor? The quick and easy way is to graph it. Okay, so to save time, I'm just going to graph. We got, go to my calculator, make sure I put in the right equation. One more again, because you know I've been known to maybe put in the wrong one from time to time. That's the same page. Hold on, I'm losing it. There we go. All right, so y equals x to the third, which is already there, plus 3x squared minus 16x minus 48. Graph. So my zeros are, let's see here, 1, 2, 3, x equals 4, 1, 2, -3, and -4. So +4, -4, and -3. All right. So when I go back and I look at my test, +4, let me write them down again, +4, -4, -3, right? So I'm looking for the opposite in the factors, right? So if 4 works, that means x minus 4 works, right? But remember, we're looking for which one is not a factor. You got me? If -4 works, that means x what? Plus 4 is a factor. So I can get rid of that one. If -3 works, that means x plus 3 is a factor, so I can get rid of that one. So my answer must be
Pearson, I thought
D.
I thought it was +3. It's like -3.
Nope, it was pretty sure it was negative. Yeah, -3, -4. Is that what you're talking about?
Yes, sir.
Yeah, it was +4 right here, and then -3 and -4.
Okay.
Okay. We would do the same. Hold up, nope, different question. Sorry. So 35. I tried again. I'm trying to make it as easy as possible, so I gave you the easy one of these. How do you figure out how many possible? Oh, I lied to you. I gave you the hard one again. My bad. Maybe the exam will be the positive one. Find the number of possible negative real zeros. Sorry, negative real zeros. So, what do? I plug in what for x? Negative x. Okay. So -5 times -x to the 4th plus 50 times -x to the 3rd minus 45 times -x squared. And you simplify that, okay? So that will be negative to the 4th is positive times -5 would be -5x to the 4th. That didn't change. Negative to the 3rd power is negative. So that becomes -50x to the 3rd. Negative squared is positive times -45, so minus 45x squared. And from there, you just count how many times did the sign change. We have negative, negative, and negative. None. So there are no negative real zeros for this one. Okay? Any questions? Okay? Can your calculator help you on that one? It can. Watch. I shouldn't even be showing you this, but that's the kind of guy I am. Negative 5x to the 4th, right?
Yes, sir.
Plus 50
X to the 3rd.
x to the 3rd. Oops. Nope. To the 3rd.
Minus 45x squared.
X squared. All right. And I hit graph. How many times do you have negative zeros? None. There's none over here. Okay. How many are positive? 2. There's just 2. Okay. So there you go. Easy peasy. All right. 36. I believe is that one's not marked out, right? Okay. We have to do this one. I went too far. Where's it at? Come on. Come on. There we go. I did mark out 37 and 38, though, correct? Okay, yes. Do not do those on the test. Do not do those on the test. They are from a section that we failed to go over. So you don't have to do them. So congratulations. I want to give me some room to work this 36. 36 is actually very easy. It's two fractions equal to each other. So what does that mean you do? Say again? Cross multiply. Exactly right. Piece of cake. Right? Right. Okay. So cross multiply. I'll go this way first. So we'll have 4n times n plus 5 equals n plus 3 times 4n plus 5. Everybody with me to there? Okay? I literally just cross multiply like back in the good old days. Okay? Distribute here, that'll be 4n squared plus 20n equals 4n squared plus 5n plus 12n plus 15. And then we work it. What happens to the 4n squareds? They cancel. That's a good thing, because now it's not a quadratic anymore. Okay? What do I need to do with the 12n and the 5n?
Hey, Snipe.
Yes, ma'am.
I need Madeline Davis for a checkout, please.
Yes, ma'am. On her way.
Thank you.
So 5n and 12n need to be added together to make 17n plus 15. Subtract your 17n over. And divide by 30. So what's in? 5. Ba-dow. Boom. Again, good test taking tip. It is multiple choice. You could always take the answers they give you and try them into the equation and see which one works. Okay? But that's last resort. Everybody good? All right. As I said, 37 and 38 we can skip. And 39. We told you to skip 39 too. 40. Back to degrees, minutes, and seconds. Stuff that we should be fresh on your mind because we have been doing these here pretty recently. So to change it to degrees, minutes, and seconds, remember you can again use your calculator. If you would like, you can just type in that 281.3 and then go to the angle section and go to DMS. It'll change it to degrees, minutes, seconds. But that's not any fun, so here's how you actually do it. You got 281 degrees, okay? You take your 0.3 and multiply it by what? 60. What does that give you? 18, exactly. No decimal? No cap? That's a joke. You're supposed to, yeah, there you go. Thank you. Okay. So, since I don't have any decimal, do I have any seconds? Nope. It's just 281 degrees, 18 minutes. Okay? If I had a decimal on the minutes, I would take that decimal and multiply it by 60 as well. All right. 41, you can also put in your calculator. Put it in there just like it is and hit enter, and it should give you the decimal form, I believe. I think it does that, okay? Or do it like you are here. You have 49 minutes, so basically you have 145 point, and we got to figure out what is 49 divided by 60. And 49 divided by 60, round to the nearest thousandth, is 0.817. And you just add that on to the end of your degrees. Okay? So after all those hard ones, we got a couple of those pretty easy. Okay? 42 is also pretty easy, counterclockwise. If we're rotating it counterclockwise, what are we going to multiply by? 3 times what there? Did you say 360? I'm sorry, 360. Positive 360. What if it said clockwise? It would be negative 360. So 3 times 360 is 1,080 degrees. Okay? 43 says find the least positive angle measurement that is coterminal with the given angle. So the least positive angle is the first positive angle we get to. Okay? To be coterminal, that just means we're what? Adding 360. Okay? So 120, negative 120 plus 360 is 240 degrees. Man, we are cooking with gas now. Okay? Everybody good on those? 44. Find the value of the 6 trigonometric ratios for angle A. So we got to find all 6 of them. So we're missing side A there. Everybody see that? We're just going to use the Pythagorean theorem to get it. So A is the square root of 50 squared minus 14 squared. I have to be honest, I was kind of surprised a lot of people missed this on the test yesterday. This was stuff that we had done before. So what is the square root of 50 squared minus 14 squared? You should get, drum roll, where did I lose it? I lost it. Say it again. 48. Okay. So 48 is A. 48 even? Really? Wow. Cool. Okay. So sine of A equals opposite, which is, what's opposite of 48? Over the hypotenuse is 50, and that reduces to 24 over 25. Cosine of A. What's adjacent to A? 14. The hypotenuse is still 50. That reduces to 7 over 25. And finally, tangent of A. Opposite over adjacent. So what's opposite? 48. Adjacent is 14. That is 24 over 7. And then what do we do to get cosecant, secant, and cotangent? You just flip them. Okay, so cosecant of A is 25 over 24. The secant of A is 25 over 7. And the cotangent of A is 7 over 24. Okay? Everybody good? $45, I'm going to put down here just because I got room. All right, so 45. It gives me the coordinates for 3, okay? And we have to find sine of theta, just the sine. That was sweet of them. So 4 and 3 is x and y. What are we missing? R. R. Okay, R is the square root of x squared plus y squared, right? Because R is basically the hypotenuse. So R is going to be the square root of 4 squared plus 3 squared, which is 5. Everybody remember this? Okay? So sine of theta. If you have forgotten, I'll write them over here. Sine is U rock. Cosine is excellent rock. And tangent is U excellent. Okay? Y'all remember that? So we're just finding sine. Sine is U rock. So y over r. My y was 3. My r was 5. So 3 over 5. Done. Okay? 46. Same way. You got negative 12 and 5. That's x and y. So r will be the square root. Please put your negative in parentheses. A lot of us missed this type of problem on our test because they didn't put the negative in the parentheses. It goes in the parentheses. You'll see that r is 13. We're finding the tangent of theta, which is u excellent, y over x. So what was y? 5 over x is negative 12. So to be honest, if I had been paying more attention, did I even need r? No, I could have just said, hey, it's y over x. So that was my bad. I'm sorry, okay? We're not all as smart as you. My bad. You got me. Why don't you stop me and say, hey, coach, we don't need to. There's no reason to find r there.
You're already there, so.
You're right. You're right. I was in the zone. All right. What happened? Why is that so small? I must have forgot to blow this part up. My bad. Let me see. Can I blow it up? Whoa, okay, I may have went too far. Is that good? All right, I won't say that's good. Phew. That's a lot of stuff. Okay. Solve each problem round to the nearest tenth. If, man, these are really big. If C is 16, so here's 16. I'm going to take, that's a little aggressive right there. 16A is 57 degrees, 24 minutes. We got to find B. So, what trig ratio are we going to use? What'd you say, cosine? Cosine is correct. We're looking for the adjacent. They give us the hypotenuse. So the cosine of 57 degrees, 24 minutes equals adjacent, which is B, over C, the hypotenuse, which is 16. And you just multiply both sides by 16. Make sure you put this in your calculator correctly. You should get 8.6, excuse me. Okay? Any questions? Everybody good? All right. 48. Solve each equation if theta, or if 0 degrees is less than x, or less than or equal to 360. So here I take the inverse tangent of x. So inverse tangent of square root of 3. What is that? 60. Is that correct? Yep. And then you ask yourself, all star trig class, what other quadrant is tangent positive? Quadrant 3, what would be a 60-degree angle in quadrant 3? 240 degrees. Okay? 240. 49. We are finding S. They give us side S is 9 and side R is 33.2. What trig ratio can we use to find angle S there? We have the opposite side and the adjacent side. So we use tangent. So tangent of S equals opposite is 9 over adjacent is 33.2. How do you get rid of tangent? Inverse tan. 9 over 33.2. You should get 150, what? No, 15.2. Is that what you got? 15.2 degrees. Okay? Everybody good? Almost done. Number 50 says in a right triangle ABC. As soon as it says that, I'm going to draw it because it helps to visualize it. It tells you C is the what? It tells you C is the right angle. It says angle A is 15 degrees. Little c is 37. That would be the hypotenuse. And we have to solve the triangle, round to the nearest tenth. Okay? This was the question that lots of us missed yesterday, and this was the same type of question we had on the mid-test. So we had to find all the missing parts, so we need to find side A, side B, and angle B. So, does it matter what you start with? Not really. You can find any of them at any point. I'm going to find angle B first. Okay? Angle B is going to be 90 minus 15, which is 75 degrees. And remember, this will be a multiple choice test, so if you have any answers that doesn't have 75 for angle B, you can mark those out, okay, and move on. Maybe there's only one answer that has 75 for angle B, and you're done. But we're going to pretend like it's not. To get angle or side A here, side A is what to 15? Opposite, adjacent, or hypotenuse? Opposite. 37 is the hypotenuse, so that's going to do sine of 15 equals A over 37. And we multiply both sides by 37. A should equal 9.6. Okay? And then we do the same thing to get B, only we're not going to use sine, we're going to use what? Because B is adjacent to 15, we will use cosine. But the way you work it is the same. Whoa. A little too far, there we go. The way you work it is the same. These will cancel. B you should get is 35.7. Okay? Everybody good? $51. Let me erase. Everybody got the work? About to erase. On 51, does it say anything about the triangle being a right triangle? It does not. So, can we do SOHCAHTOA if it's not a right triangle? No, we can't. So, what we have to do is assume it's not a right triangle, which means we can either use law of sines or we can use law of cosines, okay? For this particular problem, we know we can use law of sines. Why can we use law of sines? Because it gives me all three angles and one side, okay? So, I know I can do law of sines. I'm going to find angle C first because it's the easiest, okay? So, C would just be 180 minus the other two angles, which is 44 and 48. So, angle C is 88 degrees. And again, that's, if you only have one answer that has 88 degrees for angle C, you'd be done right now. Okay? We're going to assume that they all have 88. Then we go to using our law of sines. So, if I want to find little a, I'm going to say A over the sine of angle A, which is 44 degrees, equals C, or excuse me, not C, but what's the angle we know? B. B, which is 76, over the sine of angle B is 48. And I just moved the sine of 44 over here behind the 76 and put it in my calculator. So A equals 76 sine of 44 over sine of 48. Put that in your calculator. You should see that A equals 71.04.
So if I'm getting not that, you know,
What did you get?
I got negative 1.75. And I was confused a while ago because I don't know how to put it in the grade or not. Because I was doing it and I kept getting this.
Okay. 71.04. We do the same thing to find little b. B, no, not little b, is it? Is it little b? Oh, okay. It is little b. How about that?
Get the little C.
No, we gotta find little c. Okay, that's right. All right, I didn't think so. Why is it not erased? There we go. So, little c over the sine of 88 is big C equals 76 over the sine of 48. And again, I'm going to move my sine of 88 over here behind 76 and put that in my calculator. That should be 102.21. Okay? And again, all this is number 51 right here. $52, I'm going to put down here because I'm running out of room fast. 52 says, given a triangle with B equals 6, C equals 8, and angle A is 42, what is the length of A? Round to the nearest 10. So we're not having to solve the triangle, thank goodness. We're only finding one side. So, do they give me all three angles? Nope, so I have to use law of cosines. And I'm finding A. Well, that's good because they give me angle A, right? They're opposite of each other. So A squared equals B squared plus C squared minus 2BC cosine of A. And basically plug everything in and take the what? Take the square root. So A squared equals 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of 42 degrees. And you just take, like I said, take the square root of that, take the square root of all of that. And that's it. Put it in your calculator, you should get 5.4. Do not use your Pythagorean theorem on that because it did not say the triangle was a right triangle, right? Okay? You're going to be tempted because it gives you B and C. You know, oh, I can just find A, use some Pythagorean theorem. Don't do that, all right? Last but not least, 53. Let me erase over here so I can get just a little more room for the last one. Yay. All right, so that's going to take a little while to erase. What's it give me to find the area? All three sides. So if it gives me all three sides, which formula am I going to use? Hero's formula. Think of G.I. Joe, the real American hero, okay? So, Hero's formula, I have to find S. It's on the board over here, okay? Do it correctly. S is half of the perimeter. And then to find the area, you say the square root of S times S minus A times S minus B times S minus C. Okay? So, let's see here if I can get my pencil back. Here we go. So, first we're going to find, this is 53, last one. All right. First you find S, 1/2 the perimeter, so 1/2 26.4 plus 24.2 plus 13.2. Anybody got that answer?
31.9.
31.9. All right. Then to find the area, it is the square root of S, 31.9, times S minus A. A was 26.4 times, I don't know, S minus, and now I messed up because I was talking. You messed me up. Okay, so S is 31.9 minus 24.2, B. And last but not least, 31.9 S minus C, which was 13.2. All right. Whew. Put all that in your calculator. 158.9. And I don't even know why I put degrees. It's been a long review. All right. It is units squared, or square units, but it's area. All right. Hope you enjoyed watching this marathon of a review. Study hard, stay above the line, and we'll see you next time.